Okay, so today I am making this binary counter, and I'm going to prototype it in Tinkercad. So a couple things that I want to be looking for here as I do it. I'm going to need 4 LEDs and 4 resistors. These are 300 ohm resistors. I can use 220s to get the maximum brightness. If I use 300s, the higher the resistance I use, the dimmer the LED is going to be. If I take the LED resistance all the way down to about 120 ohms, the LEDs will burn out. So a standard resistor that we use for this is about 220. You can use 300s, this will work just as well, but I think in my version of it, I'm going to use 220s. And I have this frequency generator here, which is sending a 5-volt square wave pulse. Look, that's not a sine wave, that's a square wave pulse into the clock. And as it clocks, this thing counts along. And we want to use that 5-volt output of the clock just to light up the LEDs. It's really, really simple, but it's going to be interesting when we do, well, as I'm making this is Thursday, tomorrow's circuit is going to be like an extension of this one. So this chip that I'm using here is not a 555 timer, it's a binary counter. And there are lots of binary counter chips out there that you can buy. There's a specific one that's in Tinkercad and it has a few quirks. So it's really those quirks that are going to make it challenging for me to Tinkercad this thing. But here I go. So in Tinkercad, I've got my mini board here, and what I've done is I've hooked up a 5-volt power supply like I usually do, positive and negative, and then I've connected the positive negative over to the other side of the board. So I've got power on both sides of the board, which is convenient. I've got a frequency generator here, and I've set the frequency to 0.5 hertz. That means it's going to blink about every 2 seconds. And that'll make it easy for me to see what's going on with my LEDs and make sure the thing is working properly. And here is the chip, 74HC93. Now, I've already gone ahead and looked at all these pinouts here and realized that that is ground. So I've gone ahead and connected that to ground. This pin over here is the power pin, so I've connected that to plus 5 volts. When I look at the rest of the pins, I find that there are a bunch that are not connected to anything. There's the power. And then here's reset number 2 and reset number 1. Now in my version here in iCircuit, there's only one reset, and that reset is actually set high to 5 volts. On these microchips, sometimes you're expected to put that pin high, sometimes you're expected to put that pin low, and I discovered that in the Tinkercad circuit, I want the reset to be low, but I don't know which one. So I went ahead and connect both of the resets on this thing to low. Setting both the resets to low is going to make sure that I get the thing behaving the right way. So, and then again, making unnecessary wires. So I've taken care of the reset. Now, my signal in, there are 2 clocks. Here's clock 0 and clock 1. I'm going to use clock 0. So this is where my clock is. And so I'm going to take the output from my oscilloscope and I'm going to plug it right in there. I've decided for myself that signal is going to be orange, so I turn that orange. And I'm going to connect the negative terminal of the oscilloscope to black. That way I know that that's grounded. So now I've got my signal input to the clock, and what that's going to do now when I turn this on is it's going to clock these outputs. Output 2, output 1, output 3, and output 0. They're not in sequential order. 0 is the first one, 1, 2, 3, 4, but they're not in order as the pins appear on the board, which I thought was rather weird. So those outputs need to light up my LEDs. So what I'm going to do is I'm going to space my LEDs out right next to each other here by, I'm just going to drop in a wire here, and that's going to be where one of my positive outputs is going to go to an LED. Now on the LED, that right there, that's the anode, that's the positive terminal. So I'm going to drop my LED right there. So now if I positive power this, I'm going to have positive power to the LED. But that LED has to go to ground through a resistor, just like that. So what I've created there is this LED. I'm going to have from the output pin my 5 volts through the LED and then through the resistor to ground. And so that's what I have here. Now I need to do the next one, but to get my spacing right, I'm going to power the next one right there, like that. And then I'm going to take this LED, I'm going to put it there, and then I'm going to take the resistor and go to ground, just like that. And then I need another LED, just like that. Oh, 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 oh. I don't want to do that. I want to make sure I power it first. Get the power there. And I'll take this LED and whoops, and plug it in right there. And then power for the last. Well, actually, this is going to be my first one, the way that I sequence them, but it's all right. So that goes there. Drop the last of these resistors in. So I have my LEDs all lined up nice on my board, and if I power right there, it's going to go through the LED and through the resistor to ground, and my LED will light up if I get 5 volts there. So this last LED on the end, I'm going to call this LED 0. So I need to go from bit 0 all the way over to that LED. I've decided to make these purple. I don't know why, I was just sort of feeling purple. So that's 0. Where is 1? There's bit number 1. I'm going to send that over to right there. See how it's lining up to power that LED. So I'll go ahead and make that purple. And then, what am I on? Okay, now bit 2 is here. So I'm going to go from there, and I'm going to go all the way over to the second here. And I'm going to make that purple. And now where's bit 3? Here's bit 3. So I'm going to go from here, and I'm going to go to the third one, and I'll make that purple. And the 2 wires went over top of each other. And who the heck knows why? Well, it's totally okay. But why are these things out of order on the chip? There must be some reason, but I don't know what the heck it is. So now I've got the input here, which is going to periodically clock the counter, and then the counter is going to count in binary, and I'll know it because I've taken those binary output bits and used them to power these LEDs here through these resistors. And then this thing should work in advance. It's not going to. Here we go. Start the simulation. 1, 1, 1, 1. So actually, this is different behavior than I expected. Only the 1 bit is ever going hot. And that is super strange. So what I'm going to do is I'm going to connect, and I'm not sure why, I'm going to connect this output 0 to clock 1. So I have to stop the simulation. Output 0 over here to clock 1, like that. And there's that weird diagonal that goes under the chip there, sort of cheating a little bit, and I'll start the simulation. There we go. And for some reason now it's counting in binary correctly the way that it does. So that's just in the instructions of that chip. How did I figure that out? Well, I just, forced my way through it. But if I were actually building this thing, what I would do to make sure that I understood how to work it properly is I would look up the data sheet for the 74HC93, probably one made by Texas Instruments, and they provide a PDF file that is a cheat sheet of instructions of how to use the thing and how to wire it up properly. It tells you every voltage, every current, every tolerance, every possible thing that you can know about that chip. And they have to produce that so that electrical engineers and electronics designers can figure out in advance how they're going to apply a little gizmo like this. But here it is, the binary timer. And in our next binary counter, and in our next circuit, we're going to take it to the next level.
Mm-hmm.